Hello guys, welcome back to Global Education Zone. And the last time I introduced us to a concept, and I also said that I would be explaining on that concept today. So basically, this is that concept to find the true length of the hip of a roof and its true inclination to the horizontal and vertical planes, and also the development of the roof surfaces. So in this case, we'll talk about the true length of the hip of a roof. So basically, these are the true length of the hip, because this is the hip here. So when we look for the true length of this curved surface, it is how it will look in the development. So this from J to H is not the true length. The actual true length is from J to G. So and this is just like the previous episode where we talk about a tray with a sloping side, but only that in this case the tray is sloping inwards. But still that doesn't make any difference. The procedure is almost similar. So the first thing to do is you take the vertical height AB. So this is vertical height AB of the roof, and draw it perpendicular to the plan of the hip as shown. So basically you can see that this is the plan of the hip. So basically this is JH is the plan of the hip. Now you draw that perpendicular to the plan of the hip. So basically just pick the plan of the hip. Like from this, these are all hips. JH is a hip, HF is a hip, AC is a hip, and then A to here is a hip. So I just pick one of the hips and then draw a perpendicular to the hip. So then I will also cut off the length of the vertical height, which is AB. So AB will be perpendicular to this hip AC. So I hope you can see that. Then that means when we draw a line from the ends of those lines, the free ends, to form BC, and that BC will be the true length of the hip. So all you need to do is just open your compass and cut and turn around. Put this as A, turn around till it cuts this projection of the inward slope of the, just cut it. So when you cut it, you have DC. Then you also turn around here. So in the same way, that's similar thing you do. So you drop perpendicular to CF from A. So perpendicular to CF, this CF from A, drop it down, and then we center C and radius CB. Draw an arc to cut the perpendicular from A at D. So we center C and radius CB, yes. So I'll draw an arc to cut it, just as I explained. And then you draw DE parallel to FC. So from D to E. So we have the DE be parallel to this FC. So and then to also, when you draw a perpendicular, to also cut it at E. So that will complete the development of surface X. So this is surface X here. This is how it looks in real life. But when you are looking at it from above, it actually looks reduced. This is how it looks. It looks like this. But when you are looking at it in the development, it looks like this. So that's when you have laid it flat out. So it's the same thing here for this one. With center F and radius FE, we will draw an arc to cut a perpendicular to FG from H. So when I draw a perpendicular to FG from H, so I'll just draw an arc to cut it, and that will be G. So that our G would give us the development of the other surface. And then for this one also is similar. All you need to do is you just draw a perpendicular here, and then you cut it around here. You get for this one. So there's an explanation for that, because this is the explanation. Now this pictorial view of the roof will illustrate the application of a right angle triangle to determine the true length of the hip. So in this case, we have this this triangle here. Actually, this is actually how the hip looks. It looks like from here to here. It looks from here to here. But when we project a perpendicular downwards to meet the base of this surface, that would give us how the hip looks when it's seen from above. So from above, it's seen as AC. So you can see that similar to this AC here, it's seen as AC. That means if we now do the reverse, if we now construct a perpendicular from A to B, and then we join it to C, that BC will actually be the true length of the hip. So you can see that this AC, it is the plan length of the hip, but BC, it is actually the true length. So that is the explanation for why we had to do this process. So when you are looking at drawings in technical drawing, what you actually see are the plan lengths. So for inclined surfaces, you only see the plan length. That is how it looks when it is on the horizontal plane. But when you actually perform some constructions, it's possible to know the true length of a shape. Thanks for watching.